When humanity first lifted its gaze to the night sky, awe and confusion resonated deep in our hearts. Countless stars shimmered overhead, and the Milky Way stretched across the heavens like a river of light. Ancient thinkers asked, where did the universe come from? Was it eternal and unchanging, or did it have a beginning? For millennia, philosophy and religion offered countless answers. Some claimed the universe was crafted by divine hands. Others believed it had always existed, without beginning or end. But science reveals something more profound. The universe is not static. It has a beginning, a history, an evolution, and perhaps an ultimate fate. Modern cosmology allows us to peer back roughly 13.8 billion years. That moment is known as the Big Bang. The term is often misunderstood. Many imagine an explosion in the darkness, like a bomb going off in space. But the Big Bang was not an explosion within space, it was the sudden expansion of space itself. Time and space were born together in that instant. To ask what came before makes no sense, because before did not exist. This is the first shock of modern science. The universe has a beginning. Time and space are not eternal, they came into being in a single, awe-inspiring moment. Scientists discovered the expansion of the universe by observing the motion of galaxies. In the early 20th century, Edwin Hubble revealed that nearly all galaxies are receding from us, and the farther away they are, the faster they retreat. It is like inflating a balloon, with dots on its surface drifting farther apart as the balloon grows. If the universe is expanding now, what happens when we rewind time? The answer is breathtaking. All matter and energy collapse back into a state of unimaginable heat and density. That, scientists believe, was the universe's beginning. In that primordial instant, temperatures were so extreme that no familiar form of matter could exist. Not even atoms, particles, or the fundamental forces of nature had separated. Human language falters in describing this state. Only mathematics can truly capture it. Space itself ignited in that moment. Energy filled every corner in a blazing, compressed firestorm. As expansion began, temperatures dropped, and the four fundamental forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force gradually separated. This breaking of symmetry laid the groundwork for all matter. It was as if a lamp had been lit in the void, illuminating both the cosmos and humanity's eternal pursuit of its origin. But the Big Bang is not the whole story. Scientists realized it could not explain certain mysteries. Why is the universe so uniform on large scales? Why does the cosmic microwave background glow at nearly the same temperature in every direction? Without some deeper mechanism, such harmony seems too coincidental. Thus, physicists proposed a stunning idea: cosmic inflation. Between 10:36 and 10:32 seconds after the Big Bang, the universe underwent an expansion so rapid it defies imagination. In that fleeting instant, its volume grew by at least 1026 times. If the universe had been smaller than an atomic nucleus, by the end of inflation, it could already be larger than what we observe today. It was a true cosmic dance. The universe, in silence, stretched quantum fluctuations into macroscopic variations. These tiny irregularities became the seeds of galaxies and clusters. The Milky Way, the Andromeda Galaxy, and the vast cosmic web all trace their origins to that brief, violent expansion. Inflation explains why the universe is so smooth and why its structures could form. From the very beginning, cosmic history was written in strokes both chaotic and grand. After the frenzy of inflation, the universe continued to expand and cool. In its earliest moments, it resembled a seething ocean of fire. Energy, electrons, protons, and photons mixed together in an opaque plasma. There were no stars, no galaxies, only chaos. Light itself was trapped, endlessly scattered in the dense fog. But expansion brought cooling. Around 380, 0 years after the Big Bang, temperatures fell to about 3000 Kelvin. Electrons and protons finally combined to form neutral hydrogen atoms. For the first time, the universe became transparent. This moment is called the era of recombination. Photons were freed from matter's grasp and began streaming through space. Those ancient photons still reach us today, stretched by billions of years of expansion into faint microwaves that permeate all of space. We call this glow the cosmic microwave background radiation, CMB, the universe's very first portrait. By observing the CMB, scientists peer back into the infant universe. Its tiny temperature variations reveal the primordial seeds from which galaxies would one day grow. Even now, if you turn on an old analog television and see static on the screen, about 1% of that snow comes from this ancient light. It whispers across the ages. The universe remembers its birth. After recombination, the universe entered a long era of darkness. There were no stars, no galaxies, only vast clouds of hydrogen and helium drifting in silence. This was the cosmic dark age. But gravity worked quietly, drawing matter together. In certain regions, hydrogen and helium gathered, densities rose, and eventually, under the relentless pull of gravity, collapse ignited the first stars. These stars were far larger and hotter than most we see today. They lived fast and died young, yet played a pivotal role in cosmic history. Inside their cores, hydrogen and helium fused into heavier elements: carbon, oxygen, iron. Without these elements, there could be no Earth, no oceans, no life. The first stars were like fire, kindled in the void. Their light ended the darkness, and when they died in violent supernovae, they scattered their newborn elements across the universe, seeding future worlds. Galaxies soon followed. Under gravity's hand, clusters of stars bound together, shaping the grand structures of the cosmos. Our own Milky Way formed through this slow, majestic process. From nothingness and silence, the universe had kindled its first blaze. The stars were its eyes opening for the very first time. The birth of stars meant more than light. It meant creation itself. Today we know that the essential ingredients of life, carbon, oxygen, nitrogen, iron, were forged inside stars through nuclear fusion. When massive stars ended their lives, supernova explosions hurled these elements into space. They drifted across the cosmos, joining new clouds of gas and dust, forming new stars, planets, and eventually, life. This is why astronomer Carl Sagan declared, "We are made of star stuff." One dr, Boriside, Biars. It is not mere poetry, it is scientific truth. Every atom in your body, every breath of oxygen, every drop of iron in your blood was once forged in the heart of a star. We are not separate from the universe. We are its children. The cosmos lives within us, even as we live within it. Among the cosmos lies a strange truth. There exists something we cannot see or touch, yet its influence is undeniable. It does not shine, it does not burn, but it shapes the galaxies and binds the universe together. This is dark matter. Scientists discovered that galaxies rotate far too quickly for visible matter alone to hold them together. By all rights, The stars should have flown apart into space, but they remain bound, held by an unseen mass. Dark matter is that invisible glue. It outweighs ordinary matter by about 5 to 1. Everything we see, stars, planets, gas, dust, accounts for less than 5% of the universe. The rest is hidden. If dark matter holds the cosmos together, dark energy pushes it apart. In the late 20th century, scientists observed distant supernovae and made a shocking discovery. The universe's expansion is not slowing down, it is accelerating. Some mysterious energy is driving this acceleration. We call it dark energy. It makes up nearly 70% of the cosmos. And so, a humbling truth emerges. The world we know is only a fragment. Most of the universe is darkness, unseen but dominant. From the fiery beginning 13.8 billion years ago to the present, the universe has undergone a grand evolution. But what does it look like now? Scientists define the observable universe as everything we can, in principle, see. Its radius is about 46 billion light-years, containing hundreds of billions of galaxies. Each galaxy holds hundreds of billions of stars. Our Milky Way alone has more than 100 billion suns, and many may host their own worlds. And yet, this is only the portion we can observe. Beyond our horizon, there may lie uncountable realms, perhaps infinite. Against this backdrop, humanity seems almost insignificant. Our Earth is but a speck on the edge of the Milky Way, and the Milky Way itself is but a city among countless others. As Carl Sagan said, the cosmos is not required to be in perfect harmony with human ambition. But it is within this vastness that we have found our home. The universe continues to expand. Galaxies drift farther apart. We are like travelers upon a river, carried ever forward, and every river must one day meet its end. We now understand the universe's origin, but its future remains a mystery. Scientists envision several possible destinies. Each is profound, each is humbling. If dark energy continues to dominate, expansion will accelerate forever. Galaxies will drift beyond one another's reach. Stars will exhaust their fuel and fade into darkness. Eventually, the cosmos will cool toward absolute zero. Matter will freeze into lifeless dust, adrift in an endless night. This fate is called heat death, or the Big Freeze. The universe will die not with fire, but with silence. Another possibility: gravity may someday halt expansion. If so, the universe could stop, reverse, and collapse inward. Galaxies would converge, temperatures would rise, until all matter returned to a singular point of infinite density. This fate is known as the Big Crunch. Perhaps, after collapsing, the universe could ignite again, another Big Bang, another cycle. The cosmos might be eternal, reborn again and again. There is also a more extreme vision, the Big Rip. If dark energy grows stronger with time, it could overwhelm all forces. Galaxies would be torn apart, stars ripped from their systems. Planets, atoms, even subatomic particles would unravel. In this fate, space itself would be torn asunder. The universe would not simply grow silent, it would be annihilated. Three fates: the icy stillness of the Big Freeze, the fiery rebirth of the Big Crunch, the violent annihilation of the Big Rip. Each is a possible final chapter in the cosmic story. When we speak of the universe's beginning and end, we are left with questions that cut deeper than science. What are we? What meaning does our existence hold within this vast, indifferent expanse? Science tells us the universe began 13.8 billion years ago. Stars forged the elements, stardust formed planets, and life emerged. Philosophy asks, was this inevitable or merely an accident of chance? On cosmic scales, Earth is less than a speck, and yet, on this fragile speck, beings arose who can contemplate the cosmos itself. As Stephen Hawking once said, we are just an advanced breed of monkeys on a minor planet of a very average star. But we can understand the universe. That makes us something very special. If the universe's fate is death, whether by cold, collapse, or rupture, should we despair? Perhaps not. For it is precisely the inevitability of the end that gives our fleeting lives meaning. Against eternity's silence, every thought, every act of love, every moment of discovery shines all the brighter. We are the cosmos made conscious. We are its memory, its witness, its voice. From nothingness to light, from chaos to clarity, from stars to life, the universe's story is more majestic than any myth humanity ever told. One day, whether by ice, fire, or rift, the cosmos may meet its end. But until that day, billions of years remain, and we are here now, alive in its unfolding. The French philosopher Pascal wrote, "Man is but a reed, the most feeble thing in nature, but he is a thinking reed." We are fragile, yes, but our thoughts, our wonder, make us great. The universe may not pause for us, but within its vastness, we can carve meaning, final reflection. So, when you look up at the night sky, how do you think of the universe's fate? Does knowing its inevitable silence make you value your life more? Share your thoughts. And if you've enjoyed this journey, like and subscribe. So together, we may keep asking, in the infinite darkness of the cosmos, who are we?